There are various areas or facets of our existence that are a mystery to us, do you agree? A supposed truth behind various religions, the existence of life on other planets, the very meaning of life itself. Everything we can think about, question, theorize, discuss, and even feel, but that is not always tangible to our knowledge, at least if we take into account a more pragmatic, scientific perspective. Sometimes, these enigmas can paralyze us, but most of the time, they intrigue us, provoke us, and help to fuel our curiosity and our desire to know more about the world, the universe, and, of course, ourselves. That is the goal of our video today. We will explore and analyze some theories and hypotheses that, although not yet universally accepted as truth, offer us a way to view the mysteries that surround us. Starting with something many assume as an absolute fact, the Big Bang Theory. You see, just like other postulated theories we will explore here, they are not necessarily false or true. In fact, it's likely that there are both authentic and erroneous elements in each of them. After all, this is common in our pursuit of new knowledge. Regarding the hypotheses that discuss the origin of the universe and everything within it, the Big Bang proposal is one of the most accepted in the current scientific community. That's why it's considered by many as an unquestionable truth, but the fact is that it continues to be investigated, and the results, as we will see shortly, are quite promising. It was first proposed in the 1920s by Belgian physicist Georges Lemaitre, who also served as a Catholic priest. That's right, science and religion are not as opposed as we tend to believe. Of course, the physicist had a cosmology, that is, a worldview and universe different from what we know today, but he still managed to describe quite accurately what would later become the hegemonic hypothesis in scientific thought. At the time, George referred to the idea as the hypothesis of the primeval atom. And that was essentially what his principle postulated. A small point. A singularity with a high concentration of energy that rapidly expanded or exploded and gave rise to everything we know. This might seem common to us now, but it was quite revolutionary and controversial at that time. Can you imagine that? A single point where everything that exists is concentrated? This would have happened about 13.8 billion years ago. Right after this collapse, so to speak, the universe began to expand and cool down. Sometime later, it stabilized enough for the simplest atoms, hydrogen and helium, to emerge. And gradually stars, galaxies, planets, everything, literally everything, formed. The first evidence supporting this idea came a few years later, in 1929, through the observations of astronomer Edwin Hubble, a physicist who years later was honored by having the most well-known space telescope named after him. In his research, he noticed that galaxies were moving away from each other, which would be proof that the universe was indeed expanding, as postulated by the Big Bang Theory. Another quite promising indication was the discovery of the cosmic microwave background radiation, a phenomenon first described in 1964 by scientists Arno Penzias and Robert Wilson. This is an electromagnetic radiation present throughout the universe, in the microwave band, and is considered as a remnant of the heat emitted by the Big Bang. It's because of this and other evidence that this theory has become one of the most accepted by the scientific community. However, it still leaves some gaps, and perhaps the main one is what existed before the Big Bang. The most plausible answer might be nothing. But if nothing existed, where did the point of energy that expanded, giving rise to everything, come from? How could a single point sustain the accumulation of so much matter and energy? From here, the questions keep multiplying. The gaps left by these inquiries can be filled in various ways. Some will attribute these mysteries to God, others will compose new theories attempting to explain the phenomena from the point where the previous hypothesis could no longer evolve. This is what happens with the Ecpyrotic theory or Ecpyrotic model. This term is derived from the Stoic philosophy word epeirosis, meaning conflagration, destruction, or conflict by fire. It's a concept that would represent the cyclic notion between destruction and rebirth. As we can infer for this perspective, the Big Bang event is not necessarily the origin of the universe but rather the representation of a stage. This means that yes, everything we've seen so far matches reality, we are indeed in expansion. The background radiation shows traces of the cooling of the heat caused by this explosion. But this would not be the beginning of everything, just another stage in a cyclic movement of expansion and contraction. According to the predictions of the Big Bang Theory, our universe will expand to a point where all forces come into balance and there are no more energetic exchanges. Everything will be at the same temperature, same movement, same state. Of course, this will only occur billions and billions of years from now, but at this moment there will be no more expansion, heat, anything we know that enables life. It will simply be the end of all universal processes. For the Ecpyrotic theory, however, this is just a new beginning. After the universe reaches its peak, it will enter a cycle of contraction, returning to the state where everything is concentrated in just one point, and then it will expand again. There is a similar idea, linked to the Big Bang Theory, known as the Big Crunch. It also postulates that, at the end of the universe's expansion, it might collapse and retract, but the cyclical component of this process, as we are getting to know, is something inherent to the Ecpyrotic model. This hypothesis answers the question of what came before the Big Bang with another Big Bang, but ultimately, it cannot pinpoint what lies behind this mechanism, that is, the beginning of this cyclic movement. Moreover, it's difficult to sustain the energetic calculations of the universe's expansion and contraction through this model's lens, as there's always a loss in any energy exchange, and this would cause issues in an infinite cyclic movement. However, it's likely that the most significant criticisms of this perspective are related to the use of concepts from string theory. It postulates that particles, instead of being small static components, are formed by vibrations of tiny strings. This is quite promising. Yet, there's nothing to prove these and other hypotheses conclusively. Especially because, to support them, it would be necessary to conceive of a reality in 11 dimensions, 1 temporal and 10 spatial, not the 4 we're accustomed to. This doesn't mean that these theories are wrong, but rather that they are still in a very theoretical state, where very little can be definitively stated up to this point. Now, speaking of multiple dimensions, what if the answer we seek is elsewhere, say, another universe? That's precisely what the multiverse theories propose. You heard right, theories, indeed, in the plural, with an S. They suggest that maybe we're searching within a very limited reality. It might be that, besides ours, there are other realities, other worlds. Not just other planets, but other existences. Other universes, indeed. The most famous among them, and perhaps the most accepted, is the theory of the multiverse formed by a constellation of bubbles. It might seem strange at first glance. But it's precisely based on what we've just seen, the concept of cosmic inflation. According to this perspective, our universe is expanding in an infinite vacuum. But assuming this means also opening up to the possibilities that maybe this vacuum isn't so empty, but that it inhabits other universes expanding just like ours. In this view, they could inflate like a balloon, which seen from a certain perspective appears like a cluster of bubbles, hence its name. The Big Bang could even be explained as a collision between one or more of these bubbles, causing the effects we measure today, such as the drifting apart of galaxies and the observation of background radiation. Moreover, not necessarily all bubbles behave in the same way, meaning perhaps the physical laws we know do not apply to all realities, opening a vast array of possibilities we still cannot access. There are also other perspectives that go even further. Physicist Hugh Everett proposed in 1957 that, according to the interpretations of some properties of quantum mechanics, the existence of other realities, other dimensions, and universes wouldn't just be possible but could also be reflections or alternatives to this same reality we're part of. This is the interpretation of the multiverse or parallel realities. And perhaps this didn't sound so strange to you, as it's currently quite popular in science fiction series, movies, and books. The laws of quantum mechanics show that our phenomena are much more probabilistic than determined, and it's possible that some of the expected outcomes occur not here, but in an alternative reality. Another timeline, parallel to ours, that is affected and affects us, depending on what happens. The fact that we're accustomed to dealing with this in fictional works makes all this sound somewhat absurd. However, just as there are no instruments capable of proving these theories yet, we can't entirely dismiss them either, right? It might just be a matter of time before our understanding of life, truth, and the universe is revolutionized. Thinking in this way, you might have even forgotten the initial questions we posed at the beginning, right? What does the future hold for us? That's it for now. See you next time.